Thermodynamics is a branch of physics that deals with the relationship between heat and other forms of energy. In particular, it describes how thermal energy is converted to and from other forms of energy and how it affects matter.
Explain the Zeroth law of thermodynamics. The law says that if a body A and B are separately in a thermal equilibrium with the third body, C, then A and B are in thermal equilibrium with each other if placed in a thermal contact. So that means if we have two bodies, A and B, with the same amount of heat, at the moment that we put it together and they have contact, they're gonna have the same amount of heat, so they're gonna be thermal equilibrium. So if we grab another object C, and we put it together with object A, we're going to get, first, maybe the object A has a little amount of heat. So at the moment, they're going to be a heat transfer, but with time, both objects are going to be the same amount of heat, so they're going to be thermal equilibrium.
Well, here is an example of Zeroth law of thermodynamics. We have the problem that say that 1 kilogram of liquid H2O, that is water, at 10 degrees is added to 10 kilograms of liquid water at 50 degrees. What is the temperature of the water when it reaches thermal equilibrium? We know that the thermal equilibrium will be the final temperature, right? We refresh. Delta T is the change in temperature, C is the heat capacity, and M is the mass in kilograms. So the formula we have, there's no change of phase because here is said that both of the substances are liquids. So the formula is MC delta T. We're looking for TF, right? So we only have to substitute. M of the first substance, that is 1 kilogram. C, that is the heat capacity, that it's 1 calorie. TF, that we don't have it. And 10 degrees, that will be the initial temperature. And in the second is the same. Then we only have to multiply them. We have TF and TF, so we have to summarize them. To add them, sorry. Then we will have that 510 is equal to 11 TF. We're looking for TF, so TF will be 510 over 11, and the final temperature will be 46.36. Thank you.
The first law of thermodynamics is a version of the law of conservation of energy. It's adapted for thermodynamic systems. The law of conservation of energy states that the total energy of an insulated system is constant. Energy can be transformed from to another, but cannot be created or destroyed. The first law is often formulated by stating that the change in the internal energy of a closed system is equal to the amount of heat supplied to the system minus the amount of work done by the system. So here is the formula, and it says change in internal energy equal to heat added to the system minus work done by the system.
As it was explained, the first law of thermodynamics explains how the internal energy on a system works. And here is an example. 60 joules of work is done on a gas, and the gas loses 150 joules of heat to its surroundings. What is the change in the internal energy? So what we need to understand first is how is the system working. It says that a work is done, and because of this work, it's going to lose some heat. Okay? And this is our formula, that the change of energy, of internal energy, is equal to the amount of heat added or loses minus the work done in the system. So we're going to apply the formula in our problem. We know that the heat use is 150 joules, but we know that it's negative because it's losing and it's not adding. So it's minus 150 joules. And also we know that the work done is 60 joules. So we only have to substitute in the formula. Our heat, that is negative 150, minus the work, that is 60 positive, right? So we use math, and we know that the result is 210 joules. Thank you.
Thermodynamics is a branch of physics that studies heat, work, temperature, and energy. We can conclude that energy can be presented in so different ways and can be used to do different processes. Energy can be manipulated in so many ways, but at the end it will not disappear, because we can confirm that energy can't be created nor destroyed, just transformed. Thank you.